Hello, I'm Jonathan Aldrich, and I'd like to talk about how we could contribute to the DARPA Tractor program through an extension of some of our work on the semantics of Rust and C interoperation, as well as possible multi-threaded translation. I'm a professor at Carnegie Mellon University. I was the PI of the Model-Based Adaptation for Robotic Systems project in the DARPA BRASS program. I've also PI'd for a sequence of DoD-sponsored science and security projects. I work in formal models, verification languages, and tools. Some possible contributions include being a subcontractor in support of a TA1 proposal, where we could help achieve and validate correct translations, and perhaps a prime or subcontract for a TA2 proposal, exploring correct multi-threaded translations. Our secret sauce is something called gradual verification for Rust. What that is basically a seamless way to combine static and dynamic verification techniques so that they work on partly specified code. It's analogous to gradual typing, such as TypeScript, which adds types gradually to JavaScript. So what about Tractor? Well, Rust is a safe language, but a lot of Rust code must interoperate with unsafe C. And in fact, the output of Tractor may still do this. For example, when a program uses C components, maybe some of them cannot or should not be translated to Rust. Dan confirmed to me in earlier conversations that this is potentially of interest in the program. We built a gradual verifier for the Rust memory model. What it does is it extends the MIRI tool to check not just that unsafe Rust follows memory rules, but that C code that's linked with Rust follows the memory rules of the Rust code. And to do this, we added an LLVM interpreter to run the C alongside the Rust. We did an empirical study. We found many bugs in production Rust crates, including some very widely used ones. There's a paper link. In particular for Tractor, we believe our gradual verifier could identify problems in a candidate translation and suggest fixes. In fact, we're already working on fixing proofs in one of our science and security projects. Because we can detect errors with synergistic static and dynamic analysis, we believe we can find more issues and find them more quickly than competing technologies that just use one of those two. As far as TA2 goes, we would like to extend our gradual verifier to concurrent Rust and then apply it to ensure that translated code preserves the semantics of the original code. There's a lot of detail to be filled in here. We're looking forward to seeing the BAA, and we'd love to talk about other ideas in this general area as well. Please reach out to me at the email address on the first slide. Thanks.